Statistics and Mechanics, Paper 3, Mathematics Advanced Level. Answer all questions and ensure that your answers to pass-up questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this paper is 100. Question number 1. Helen believes that the random variable C representing cloud cover from the large data set can be modeled by a discrete uniform distribution. Write down the probability distribution for C. Part A. Using this model, find the probability that cloud cover is less than 50%. So you can have a look at this scale. This represents no cloud. There's 1, 2, 3, 4, 5, 6, 7, 8. So if we look at this to help us understand it, cloud cover is measured in eighths, which is called octas. So cloud cover is measured in eighths, which is called octas. Cloud cover is the fraction of the celestial dome covered by cloud. The fraction of the celestial dome covered by cloud. So we have here cloud cover, and then we have the symbol for cloud cover. The scale in octas or eighths. So 0, sky completely clear. If you look at this picture there on the right hand, top right, that sky is completely clear. You cannot see any white cloud on it, in it. So sky completely clear, so it's 0. And then you can go to 1, you can go to 2, you can go to 3, and let's look at 4. Sky half cloudy. You can see the picture there, there's half of the thing is covered with clouds. So we will represent it as the sky is half cloudy. So you can see half of it is shaded. Half is shaded. That means half of the sky is covered. We go 5, 6, 7, and for 8, the sky is completely cloudy. You can see that this probably is taken from a plane above. You can see everything is covered. If you're inside a plane and you've gone above the clouds, you can look and you can see the cloud completely covers the earth there. So there's everything is shaded. So it is all shaded because the sky is completely cloudy, covered by cloud. So it's important to have that idea what it is. Now, we can write for probability of cloud cover, 0 is 1 over 9 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to get 0, completely clear sky is 1 out of 9. To get the 1, it will be 1 out of 9. To get the 2, it will be 1 out of 9. 3, 1 out of 9. To get half sky, cloudy half, 4, it will be 1 out of 9. To get the 5 is the 1 out of 9. 6 is the 1 out of 9. 7 is the 1 out of 9. To get the sky to be completely cloudy, which is number 8, you get 1 out of 9. You can put it like that in a table, or you can write it in this form. Probability of cloud cover to be equal to C is 1 over 9. You put from 0 up to 9. That means C goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From this 0 up to that 9, because you are using all the 9 numbers. For question 1b, Using this model, find the probability that the cloud cover is less than 50%. So for it to be less than 50%, we can say probability of cloud cover is less than 4, because we have, that would be 50% and then the other one 50%. So probability of it less than 4. So one probability of cloud cover to be 0 plus probability of cloud cover to be 1, probability of cloud cover to be 2, probability of cloud cover to be 3. So for it to be less than 4. So probability of 0 is 1 over 9. Probability of 0 is 1 over 9. Probability of 1 is 1 over 9. Probability of cloud cover to be 2 is 1 over 9. For it to be 3 is 1 over 9. We add all of them, gives you 4 over 9, which is 0.444. The next part says, Helen used all the data from the large data set from Hearn in 2015 and found that the proportion of days with cloud cover of less than 50% was 0.315. Comment on the suitability of Helen's model in light of this information. So I've taken a picture of a page of the large data set. So this is from the large data set, from the large data. So you can see on the top right there, it says Hearn, H-U-R, top left, H-U-R-N. And it gives you, we want to look at the daily mean cloud cover. I've highlighted it in yellow. The daily mean cloud cover I've highlighted in yellow in octets. And you can see the numbers there. It puts the date. On the 1st of May, it was 8. On the 2nd of May, it was 8. On the 3rd of May, it was 7. So you can see on the 4th of May, it was 5. On the 5th of May, it was 6, and so on. So that shows the daily mean cloud cover in that octa scale. 887, that's the daily mean cloud cover. So that's what the large data set shows you. So if all data was used and we had 0.315, the 0.315 is given to us. But if we look at Helen 0.444, so we can see that the probability of the cloud cover for Helen less than 50% is 0.315. And 0.315 compared with 0.444. 0.315 is less than 0.444, which we got from that calculation. So the proportion of days with cover of less than 50% is lower than that expected. Therefore, the model may not be suitable. So the proportion of days covered is lower. 0.315 is lower than what was expected, so the model may not be suitable. So probability lower than expected suggests the model is not good. Suggest an appropriate refinement to Helen's model. Cloud cover will vary from month to month and from place to place. So use a non-uniform distribution. So the cloud cover, it varies from month to month. So that large data goes from May to October. So the cloud cover varies from month to month, and also place to place, it changes. So we use a non-uniform distribution for that. Question number 2. Tessa owns a small clothes shop in a seaside town. She records the weekly sales figure, W pounds, and the average weekly temperature, T degrees Celsius, for 8 weeks during the summer. The product moment correlation coefficient of this data is minus 0.915. Stating a hypothesis clearly and using a 5% significance level, test whether or not the correlation between sales figures and average weekly temperature is negative. Suggest a possible reason for this correlation. So what we want to do is H naught rho is equal to 0. H1 rho is less than 0 because it says negative. So it's less than 0 because it says negative. N is 8, which is a sample size, which is for the 8 weeks. Sample size is 8. So if we look at this diagram, H naught, this is 5%. On this, in this section, you will reject H naught. On this section, accept H naught, which is 95%. So we have minus 0.6215 on this point here, and then minus 0.915. So therefore, reject H naught. Evidence to suggest a negative correlation because critical value is minus 0.6215 and R is less than minus 0.915 is less than minus 0.6215. So significant result, and there is evidence of a negative correlation between W and T. So you go to page 37 of the formula book for critical values for correlation coefficients. So this table concerns tests of the hypothesis that a population correlation coefficient rho is 0. So go to page 37 of the formula book. And when I zoom in, you look on the column for sample size N. Sample size is 8. You go is 5%, which is 5 over 100. So you look where the sample size of 8 and 5 over 100 meet is 0.6215. So you can see there's 0.6215. That's where we got that number. Sample size is 8 and 0.05 and 0.6215. For question 2b, suggest a possible reason for this correlation. As temperature increases, people spend more time on the beach and less time shopping. As temperature drops, people are more likely to go shopping than go to the beach. Or as temperature increases, people will be outside rather than in shops. Those are the things you can write for that one. Question 2c. Tessa suggests that a linear regression model could be used to model this data. State, giving a reason, whether or not the correlation coefficient is consistent with Tessa's suggestion. So since R is close to minus 1, it is consistent with the suggestion. So we can say when it's close to minus 1, it is a strong, you can use that word strong, or significant, or near perfect correlation because R is close to 1. It is consistent with the suggestion. Part D, state, giving a reason, which variable would be the explanatory variable. T will be the explanatory variable since sales are likely to depend on the temperature. So W depends on T. The sales depends on the temperature on T. Or W responds to T. The sales responds to the temperature. Or T affects W. T affects the sales. Temperature affects the sales. And how do you know what explanatory variable is? Explanatory variable goes on the x-axis. So what you put on the x-axis is explanatory variable. For example, financial damage in thousands. And then the response variable goes on the y-axis. So number of firefighters. So explanatory variable would go on the x-axis. That means T will go on the x-axis. And W would go on the y-axis, the response variable. Tessa calculated the linear regression equation of W is equals to 10,755 minus 171t. Give an interpretation of the gradient of this regression equation. If you write it like y equals to mx plus c, minus 171 is the m, which is the gradient. So minus 171 pounds. And c is 10,755. So we can write W is equals to minus 171t plus 10,755. So the gradient is the rate per degree Celsius. The rate per degree Celsius. So every degree rise in temperature leads to a drop in weekly earnings of 171 pounds, because the gradient is negative. So that's why we have a drop or a fall. It's negative gradient. So every degree rise in temperature, as places get hot by 1 degree, it leads to a drop in the weekly earnings of 171 pounds. So the weekly pay earnings reduced by 171 pounds. At time t seconds, where t is greater than or equal to 0, a particle p moves in the xy plane in such a way that its velocity is given by that expression. When t equals to 1, p is at the point A, and when t equals to 4, p is at the point B. Find the exact distance AB. So we're going to be using some of this formula here. I've just put them in bracket in red. Velocity is ds over dt, differential of displacement over time. Acceleration is dv over dt. Acceleration is d squared s over dt. Displacement is integral of velocity with respect to time, and velocity is integral of acceleration with respect to time. So as you go down this way, you differentiate. You're going up that way, you integrate. So it's important to remember that. So want to get R, we integrate V dt. When you integrate, you add 1 to the power, and then you divide by that new power. So t to the minus a half, you add 1 to minus a half, and divide by minus a half plus 1. When you add 1 to minus a half, you get a half. So t to the half divided by a half. You add 1 to t to the power 1, it becomes t squared, and then you divide by 2. So it's t to the half I over half minus 4t squared over 2j plus c. Don't forget the constant of integration. 4 divided by 2, you will get 2. So that's what R is equal to. Now we need to substitute in t is 4 and t is 1 into R. So when t is equals to 4, we're going to substitute 4 there for t plus c, and that will give us this expression. R is equals 4i plus 32j plus c, and that's your OB. So we're going to do it next and substitute t is equals to 1. Next, we're going to use the time is equals to 1. We'll substitute t is equals to 1 in there, and that will give us 2i minus 2j plus c. Now, AB is the same as OB minus OA. So that's OB and that's OA. When you minus them, 4i minus 2i, it gives you 2i. Minus 32 minus 2, it gives you minus 30. And c minus c will give you 0. To find the absolute value of AB, is 2 squared plus minus 30 squared. It will give you 2 root 226. Another way you can do it to get that 2 root 226 at the bottom there, you can use x1 is 4, x2 is minus 32, y2, so x1 is 4, y1 is minus 32, x2 is 2, y2 is minus 2. and you will use the distance between 2 points, x2 minus x1 squared plus y2 minus y1 squared. So you get 2 minus 4 squared plus minus 2 minus 32 squared. Put that in your calculator, you'll get the same answer. That's another way to find that answer. Question number 7. A wooden crate of mass 20 kg is pulled in a straight line along a rough horizontal floor using a handle attached to the crate. They're giving us the mass is 20 kilograms, tan alpha is 3/4. The tension in the handle is 40 Newton. The coefficient of friction between the crate and the floor is 0.14. Using the model, find the acceleration of the crate. We need to get the diagram correct. If the diagram is not correct, it will make it difficult to do this question. So looking at this diagram, we have R is acting upwards, the reaction. The weight is acting downwards. Weight is mass times gravity, which is 20 G. And the reaction is acting upwards, R. Frictional force, the red line I've put there, is acting to the left, and frictional force is equals to mu R. That tension there is 40 newtons. So the forward force, we can have the X component of the forward force, and then there's another upward force here, which comes from the Y component of that 40 Newton. That's the force they're acting upwards. So we can do sine of alpha. Alpha is that angle there. So alpha is that angle. So sine of alpha is opposite. Sine alpha is opposite over hypotenuse. Opposite is Y. Hypotenuse is 40. Because this angle there is 90 degrees. So this is a right angle triangle. So that is a right angle triangle. Very important to see that. So take 40 to the left. That means Y is 40 sine alpha. So Y is 40 sine alpha. So 40 sine alpha is this upward force here. So we'll call this upward force 40 sine alpha. Let's look at cos alpha. Cosine of alpha is adjacent over hypotenuse. So this is the angle alpha. Cos alpha is adjacent, which we call this side next to it x, divide the hypotenuse, which is 40. Cos alpha is adjacent over hypotenuse. So if we take the 40 to the left side, comes 40 times cos alpha is equals to x. So this x here is called 40 times cos alpha. And we can call it a forward force because it's pulling it to the right. So 40 cos alpha is a forward force pulling it to the right. 40 sine alpha is an upward force pulling it up. So when we resolve vertically, vertically means going up and going down. So upward force is equals to downward force. Which forces are going upwards? If you look at the diagram carefully, R is going up. It's a force pulling it up. What else is pulling it up? This one here, due to that 40 Newton, is pulling it up. So there are two forces pulling it up. R is pulling it up, and this component of that 40 is pulling it up. So you have R plus 40 sine alpha. R is pulling it up. 40 sine alpha is pulling it up. So two things are pulling it up. How many things are pulling it down? The downward force. It's only the weight pulling it down, mg. So there's one force pulling it down. So, but it's not going up, it's not going down. It is staying in equilibrium in where it is. So that means the upward force is equal to the downward force. That's why we make them equal. Now, let's look at forward force minus backward force using F equals to ma. Let's resolve it horizontally. What force is pulling it forward? If you look on the diagram, the forward force is there. I put a circle around it. And it is this component of the 40 Newton. That's the forward force pulling that way. I put in red there. And the backward force is this one due to the friction pulling it backwards. So because it is moving, the forward force is bigger than the backward force so that it can move. And that force using F equals to ma, that force, resultant force is equals to the mass times the acceleration. So forward force is the 40 cos alpha. That's the one pulling it forward. Minus the backward force, which is the friction force, is F, is equals to m, which is 20 times acceleration, which we're going to find out. So, but do we know what F is? F is equals to mu times R. That's the formula to find friction. So to find friction, you use that formula. F is mu times R. Now we know mu is 0.14. It's given to us. So it's 0.14 times R. So we can start to use some of those to work out. So that's how you resolve it. So our two equations are R plus 40 sine alpha is 20G. That's from the upward force equals to downward force. Forward force is 40 cos alpha minus resistance 0.14 R is equals to 20A. So we have two equations, equation 1, equation 2, which we are going to solve. Now, we are given that tan alpha is equals to 3/4. Using a triangle, alpha, tangent is opposite over adjacent. So the 3 is the opposite there, which is the 3, and the adjacent is the 4. Using this right angle triangle, where that's 90 degrees. So we want to find the hypotenuse. 3 squared plus 4 squared, and square root of that would give you 5. Now we need to find sine alpha. Sine alpha is opposite over hypotenuse, which will give us 3/5. Cos alpha is adjacent over hypotenuse, which will give us 4/5. So that means, let's look at equation 1 now. R plus 40. For sine alpha, we put 3/5 is equals to 20. For G, we put 9.8. Watch that. R plus 40 for sine alpha, we put 3/5 is equals to 20 times 9.8, because they said G is 9.8. That will give R to 172. Now we know force friction is mu R. We know mu is 0.14 is given. Now we found R to 172. We multiply the two together, it gives us 24.08. And now we look at equation 2. 40 times cos alpha, which is 4/5, minus 0.14 R is 24.08, is equals to 20A. And we want to solve for A. So watch what we're going to substitute. So we're using equation 2. So 40 cos alpha is 4/5 minus 0.14 R is F, which is 24.08, is equals to 20 times A. And A is what we want to find out. So rearranging, solving this in your calculator, and then dividing by 20, you'll get, solving this left side, you'll get 7.92. And dividing by 20, you get 0.396 or 0.40 meters per second squared for A. So the acceleration of the crate is 0.396 of 0.40 meters per second squared. That's what they ask us to do, to find the acceleration of the crate. Question 7b. Explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found in part A. So you can see now you're pushing it from the front. So you're pushing it from the front. And this angle is alpha and the mass is 20. When you push in, it increases the reaction. So as you're pushing that, it increases that reaction force, which produces an increase in the available limiting friction, because friction is mu r. So when you increase r, you increase friction. Friction is mu times r. So as you're pushing down, you're increasing, r increases, and it increases friction. So friction is increased by pushing to the ground. When you're pushing down, the force causes friction. The tools, the box and the ground, they are pressing on each other and it's more friction. So increasing F friction will decrease your acceleration. When friction increases, your acceleration will decrease. So if you look at this from that equation 2, when you make this arrow to be big, that means all of this will be a big number. And when you subtract from 40 cos alpha, this side would be small. And when it is small and you divide by 20, that will give a small a, because you're making the numerator to be small. So what's happening here is you have 40 cos alpha minus 0.14 r divided by 20 is equals to a. So if you make r to be big, that means this top part will be small. And when you do a small thing divided by 20, a small number divided by 20, the value for acceleration will reduce.